behalf of Sonosco, it's my pleasure to welcome you all to our seventh webinar about asset integrity management. My name is Marcel Sminia. I'm one of the founders of Sonosco, and I will be facilitating this webinar. Today's topic is the benefits of a single source for process safety studies and SIS data. Let me start with introducing our guests of today. We have invited two industry experts to shine some light on this matter. First of all, Paul Church, and we have Sonosco's Peter Poldervaart. Paul has over 35 years of experience in aerospace, oil and gas, nuclear, rail, and automotive systems as both a technician and an engineer. And the last 9 years, he has been active in the field of safety, critical maintenance, and functional safety. He currently supports Sonosco and Shell globally as a LOPA chair and with SIS lifecycle consultancy related to IEC 61511. And Peter has more than 10 years of experience as a functional safety engineer working for Shell P&T before joining Sonosco in 2021. And for most of this time, he worked as a LOPA chair and as a SIS lifecycle consultant on projects and training programs in Shell and also for third parties to Shell. Currently, Peter is the IMS SIS Pro domain expert in Sonosco and also tool train. So before we start the outline of the framework of our discussion, we will start by exploring why a single source for process safety studies and SIS data can benefit projects and end users alike. And when we understand that better, we will dive deeper into how an integration of single source environment will work in projects and for end users. We will also look at an example of implementing an effective flow of process safety data in a project environment. At the end, we will have some time to answer questions. We have already received a few up front, but please feel free to put any questions that you may have in the chat. And also please note that for any reason you experience a bad connection on your site, a refresh of your browser will bring you back into the webinar. So let's get started. Hi, Paul. Good to see you. How are you?
Hi, Marcel. Thank you. Thanks for inviting me, and good. Thank you. I'm looking forward to the discussion.
Thanks for joining. Hi, Peter. How are you?
Hi, Marcel. I'm good. Thanks. Looking forward to the webinar as well.
Great. So let me start with you, Peter. Our topic today is the benefits of a single source for process safety studies and SIS data. Can you share some of those benefits with us?
Sure, Marcel. So one of the biggest benefits that I see is that you have a single point of entry and a single source of so-called truth during the various stages of the SIS lifecycle.
Okay, what do you mean with a single point of entry?
So with a single point of entry, I mean that from any project from its conception to decommissioning, produces several different documents and interacts with several different disciplines. So looking at the SIS lifecycle specifically, you can think of documents such as hazard study reports, LOPA study reports, SIF design verification calculations, SIF proof test procedures, and SIF proof test procedure results. So throughout this SIS lifecycle, many different discipline engineers will interact with the information that is stored in these documents for either project engineering work or when in the operational phase, their day-to-day activities, keeping the plant safe. So a single point of entry basically means that all these different discipline engineers throughout the different life cycle stages, they all access the same information from the same point of entry. So you can think of something like a URL, for example, and a user having login credentials to access a specific site database that contains master documents such as the master HAZOP reports, the LOPA study reports, and so on.
I see, but does this not pose a risk? All those people having access, being able to modify, delete data that you really want to save?
Yeah, so you're right. So that is also why when you're having this single source of entry and this single source of data, that you will need to also implement proper user management to be set up and also to be enforced by whoever owns the database. So you can think, for example, about editing rights that can be assigned to a SIF designer for only a specific unit in that database, while he or she can still have viewing rights on other modules, such as a heads-up module or a LOPA module. That person can only edit in that specific unit and only in the SIF design module, because that is his role. So depending on the role that they have in the SIS lifecycle and the capabilities that they have, you can think of many different roles that can be set up when doing proper user management, Marcel.
Yeah, clear. So what about this so-called single source of truth that you mentioned before?
Yeah, so that's actually a fairly simple concept. So whether you are a tech safety engineer or a process engineer that is accessing this single source database from anywhere in the world, you open, for example, a HAZOP report, you will both be looking at the same information, the exact same master data that is in that database. So there can be no mistake, that you're looking at the latest revision of a specific HAZOP report or a LOPA study. And so from experience, having worked myself as a functional safety engineer, I can say that getting the latest revision of a document that you would need for either your daily activity or for the project that you are working on, getting the latest revision of a particular HAZOP study or a LOPA study, that hasn't always been easy, because sometimes documents are stored in different locations. Sometimes even, somebody has it on his hard drive on his desktop PC. And sometimes it's even, stored inside a particular kind of software that I do not have installed on my PC. So many challenges sometimes with, getting these the right documents for my project. So a single source would have been more time efficient for my work back then. So, and what I would also like to say is that if you have this single source and you add to that proper user or proper revision management on that single source database, as an owner, you can also ensure then the traceability and the auditability of that data, of that SIS data throughout the SIS lifecycle, even when there are multiple MOCs or projects active on that SIS database, Marcel.
Okay, Paul, over to you. As an engineer that has worked in the field of functional safety for a very long time, different industries, this concept that Peter is describing, does that appeal to you?
For sure, absolutely. It's particularly pertinent because in the past, I worked as a functional safety focal point for one of the major oil and gas operators. And as part of that, was responsible for directly answering queries and legal challenges face to face with the state regulator. Now, that involved me having to keep track of all of the information that Peter was just talking about, actually, that's required during the functional safety lifecycle, and to use that to demonstrate the integrity of the SIS. Now, there was the HAZOP reports, the LOPA reports, the SRS documents, Then in the sort of operational side of things, you've got your proof test procedures, your periodic reviews, your FSAs, the audits, and now that was an extremely time-consuming task. It was, full-time job, and it was made harder by everything, alluding to what Peter just said, being distributed across all these numerous different applications and databases. I mean, the HAZOPs, they would come in, they might be stored in PHA Pro or PHA Works, or it might have been as a non-searchable PDF. And the information I just talked about, you need all of that throughout the life cycle. So looking, you can see that safety life cycle chart, which is a simplified version of the process flow in 61511. And it looks nice and easy, it looks nice and straightforward, but there's some key differences between at least the first two stages that can lead to some difficulties. Now, HAZOP chosen there, it's probably the most common hazard analysis technique for process plant. Now, that technique came out in the early 70s by I think it was Professor Kletz, and it's your first main risk assessment of your project or your asset, and it's a qualitative risk assessment. It's structured by node, then guide word, and for each of those guide words, your unmitigated consequences. And then after that, you then apply your safeguards, and some of those will be SIFs. Now, the LOPA technique, that's the next stage. So you've done your HAZOP, you've said, okay, we've got these safeguards, but we're not entirely sure if we've got enough of them, so we need to go a bit further than that, and we need to do some semi-quantitative risk analysis. So we're going to apply some orders of magnitude to those, and it's intended to be more detailed than a HAZOP, and the actual technique itself came out, I think it was 2001. It was the American Institute of Chemical Engineers, their Center for Chemical Process Safety. But it wasn't created with respect to specifically safety instrumented systems. It was a tool to look at that cause-consequence pair in the HAZOP, where a SIF may or may not be. Now, when you consider this chart here in respect to the functional safety life cycle, when you're looking at a SIF, it may appear as a safeguard in multiple guide words or under multiple nodes throughout that HAZOP. And to get the demand rate on that function, you need to sum all of those cause frequencies you've identified to get the demand rate on the SIF. Now, that demand rate is going to then give you your probability of failure on demand, that target, that minimum failure rate that you can endure with that SIF to cover all of those risks that you've identified. Now, that then drives your design, but it's not the only thing that drives the design, because you've got two aspects of that immediately come to light in your SIF analysis. You've got the architecture, and you've got your test interval, because let's take, for example, a SIL2. Now, you can do a SIL2, that band, you can do a SIL2 with 1 out of 1 sensing elements and 1 out of 1 file elements, if you test annually. But your site may not support annual testing. It might need to do testing, say, once every 5 years, and then you might need 1 out of 2 sensors and 1 out of 2 file elements. So you can see straight away that PFD target, it drives not only your architecture, but the actual test scheduling as well. Now, once you do your testing, you've then got to decide as part of your design what sort of test you're going to have, because then you've got to incorporate your proof test coverage factor. Now, for new projects, with the latest version of the standards, I think the vendors have to now provide, for SIL-rated equipment, they have to provide functional safety manuals. In your functional safety manual, you will find the failure rates, you'll find proof test coverage factors, and you'll find those steps required to achieve that proof test coverage factor. So you may have a number of steps for which you can take a credit of, say, 60% of your dangerous undetected failures, and then some extra steps whereby they allow you to take credit, say, for 98% of your dangerous undetected failures. So that determines your scheduling. And then, of course, the other aspect is you don't necessarily have to test full end-to-end. You can independently test separately the sensor, the logic solver, and the final element. Depends on how you manage your functional safety life cycle and your maintenance management strategy. Now, the possibilities, looking at those different modules in the chart, to make the data flow from each one of them with a lot less human interaction, you're on a greenfield project, you're clearly going to simplify the process flow. You're going to automate it and remove the human interaction. That inevitably gives you increased efficiency. And for auditing purposes and compliance purposes, you're going to have easier tracking of your SIS lifecycle. Now, throughout that project, inevitably there's going to be iterations. You're going to have different versions of P&IDs. You will have different versions of cause and effects in all likelihood. And you're going to have a management of change process for your asset and your project. Now, again, if you've got this automated single source with data flowing between these modules, then that management of change process is inevitably simplified. You're going to get a reduction in errors, omissions, and oversights. And when the project auditors come in, you can demonstrate your compliance far more easily. Now, all of that said, let's then look at brownfield. Now, all of the things I just said equally are going to apply to brownfield, but I would suggest that it's potentially more beneficial to brownfield because you've got an existing asset, you've got existing operations, you have existing P&IDs which are as built. Now, you've got a history. Those documents are all going to have to be checked out as your as built and then moved into the project area and then moved through this process flow with respect to SIS. And then when the project finishes, they will become your as built when they're all handed over to operations, and the old as builts will be made redundant and placed in some archive somewhere. And as part of that, there's you potentially you're going to be amending the testing for your existing SIFs on your asset.
So does the test scheduling also benefit from this single source?
Yeah, I think with all this data concentrated in one place, you can even think of test scheduling itself being done from that single point of entry. If you grant access to the people that have to do the testing, so the maintenance planners and the maintenance technicians. So you can think of something like a dashboard environment, maybe there where when a maintenance engineer logs into the database, he sees on his dashboard environment how many SIF proof test schedules or proof tests are scheduled for that week, and maybe even which as specific as which equipment needs to be proof tested that week. So for planning point of view, a single source would also be beneficial. And if you look at the maintenance part of it, so that the guy that has to do the proof test, so the maintenance technician, so to speak, you can even think of this maintenance technician downloading a proof test procedure that is also stored in that single source database to a tablet format. So he on a tablet downloads that proof test procedure that goes with the proof test that he has to perform, take that tablet outside and just fill out that form step by step with the data, with the measurements, can even add pictures if he wants into that form. And when he is finished, come back to the maintenance office and upload the information back into that single source database, into something like a condition history module. So that would be also, I think, would also apply for the test scheduling. A single source database would be beneficial over there as well, I think. Yeah, Paul, what do you think?
Yes, that sounds great. I'm just thinking about the days when I was a technician and the SIF testing I used to have to do, how much simpler this would have made it, rather than dragging pieces of paperwork into the field and trying to fill them out in the rain. Actually, thinking about developing that sort of data collection further, the automation of it, you could collect a proof test data set for specific equipment types. And just thinking about 61511, you've got phase 6 of the functional safety life cycle, your operations and maintenance, and as part of that, you've got your periodic reviews, and you've got, I think it's clause 16, where you've got to capture any changes that you observe which may affect the safety instrumented system and the SIF. And of course, that's going to include your SIF demands, your test results, and specifically those the failures that you find. Now, by applying the rule of statistics or rules of statistics, and I might point out at this point, I'm neither a mathematician nor a statistician, but I'm an engineer that studied some statistical techniques. If you've got a sufficiently large database, you can use things like chi-squared. You can infer failure rates. You can then use that data set you've generated from your asset, and you can compare it against some of your other company assets that you would then get in that single source. You could also compare it against the data that we've got in those published databases. So SINTEF, for example, there's a few online ones. There's also a reader, so you can do comparisons between your asset and the published ones. And then any of you who are watching who know a reader and SINTEF in detail, then specifically in a reader at the front, there's some calculations, and they're also there in SINTEF with respect to weighting the data set. So you can, if you don't have enough in your own asset, then you can weight existing published data. And the failure rates of SIS equipment, if you think about them, so again, look at a functional safety manual for, say, a logic solver, and you'll get so many failures in time, and it's 10 times, it's e to the minus 9, isn't it? So, and then say a sensor might be 1 in 200 years for a dangerous undetected failure rate. Your most likely failure in the lifetime of your asset is going to be, say, final element if it's a valve. Now, unless you've got a lot of them and your mission time, say 20 years, you aren't going to see many failures at all. So that's where you need these statistical rules to put in place and then use them to weight the existing published data and perhaps provide something more specific to the asset in question.
Okay, so having all this data concentrated in one place sounds like it benefits the engineers, no discussion about it. But looking at it from the business side of things, are there any benefits for the business with a single source approach, Peter?
Yeah, Marcel, I think actually there are many, but let me focus on the most obvious ones. So first of all, single source means single license. So single license means that you don't have to have all these different licenses and have to pay for all these different licenses if you use different software for all these different applications or all these different steps that you have to go through in the SIS lifecycle. And also administrative, you don't have to administrate all these different licenses that you have of these software packages. I'm thinking about less potential for rework. if everybody accesses the SIS data from a single source and is then also looking at, or from a single point of entry, and then all look at the same single source, so the source for master data, also the probability of maybe somebody picking the wrong document, wrong revision of document for a project or for an MOC becomes less, because everybody is tied into this single source where they get their data from. And finally, for greenfield projects, so I'm looking specifically to greenfield projects, you can think of the different steps that greenfield projects go through are typically from HAZOP to LOPA to design verification calculation. And if you can make that information used in those processes, if you can make that flow from one module to another module and sync between modules, that would save time, that would save precious time on a project, not just from translating one module data into another module data, but also from rework, right? Because we're all human. If you go from one module to another and you have to do that manually, there is a lot of probability for human error as well. And I think, Paul, some time ago you told me about a project that you had worked on that could have benefited from this flow of information between modules. So maybe you can share a bit about this.
Yeah, sure. That was last year. Very large operator in a joint venture, and I was contracted to do the LOPA chair aspect, and the project schedule was very, very aggressive. So they were having weeks and weeks of HAZOP, sort of 4 or 5 weeks just for a single module, and then they were running the LOPA straight off the back of that, and so there was no time to get a HAZOP report issued. You just got issued the latest worksheet that was being updated on that particular day. So I was getting issued in the evenings this sort of 300 to 400 pages of HAZOP worksheet, and it was in a Word document format. That was the only thing that was given to me. I think the tool they'd used for the HAZOP was SIS Pro, but the contractor for the HAZOP hadn't considered the LOPA at all. It was just come in, do the HAZOPs, off you go. So they hadn't used the LOPA modules that possibly could have been used. So the scribe, when noting things down in the HAZOP, for example, when using writing the tag number out for one of the safeguards, instead of using, say, a temperature trip, for example, instead of putting TZAHH, in some places they put TZAHH, in some places they put TZA, then the number, and the HH at the end. In some places it was a different tag number than what I'd seen in the cause and effect, so you couldn't even find it. And in other places they had the 2 out of 3, but they'd write it in a different order. So that was them making human errors, and no discredit to them. They were doing the job as best they could, but it's that, as you just said, it's human nature. When you're doing an extremely repetitive task, it's inevitable that errors are going to creep in. Now that meant that I couldn't do tag searches. I couldn't go to the cause and effects, pick a tag string, and then go and search for it, because it just didn't work. The other thing was, because they weren't concerned about LOPA in the initial stages, they hadn't identified any of the cause-consequence pairs in the HAZOP that were to be taken to LOPA. So that was down to me to identify. And yeah, it was very, very time consuming. It was very tiring. It was very repetitive, and that just exposes, some of our weaknesses as humans. Everyone on this call, we all make mistakes. That's why we use computers to automate things, because they're brilliant at doing, short, specific, repetitive tasks over and over again without any errors. And if you think about, going back to that diagram and just thinking that the whole functional safety life cycle, I know that at some point in this project, which is still not been completed, someone's got to do an FSA 3, and they've got to go back and they've got to check everything I did, everything I created in the LOPA. They've got to go back and manually check that against the Word documents that came out of the HAZL. So they may or may not see the errors I've made, but you can be guaranteed they're going to be introducing their own errors as well. So you can really see that this aspect is going to benefit greatly from a single source automated process flow.
Yeah.
Okay. Thanks, gentlemen. It's time to conclude. Paul, would you like to say some final words?
Certainly. I think the key thing for me here is that it's just worth highlighting again. Functional safety is a life cycle activity. It's not just a project stage. It's there to cover, from cradle to grave, from when you put a SIF in to when it gets decommissioned at the end of life. And therefore, it's logical that a single software application to manage that life cycle is going to be far more suitable and fit for purpose than all these different multiple tools that cover only part of that process.
Peter, any final words from you?
Well, most of what I wanted to say about the subject, I think, has been said. And I know that for some of our audience, the SIS lifecycle can be quite overwhelming. There is a lot of complexity. There is a lot of data to consider, when applying the SIS lifecycle as per the IEC. But I always say that applying the SIS lifecycle as per the IEC is like a journey. It's not something that you do in a week time or in a year's time. You take it one step at a time and work towards perfecting this during the lifecycle process, which goes on basically until the site or the unit or the plant stops operating. On a final note, maybe I would also like to say that in Synosco we do not only make software such as the new IMS SIS tool to support this single source implementation of the SIS lifecycle for either end users, companies, or for projects on EPCs, but we also have some in-house knowledge, that with which we can support our customers, in that journey, that difficult journey, that large journey that the SIS lifecycle actually is. Yeah.
Okay, thank you both. Let's move on to some questions we received. First question I have here: what are the disadvantages or cons of having a single source? You want to take that, Paul?
Yeah, that's let me do that one. Single source. Well, let's think about functional safety. One of the things we're often looking at in terms of architecture is redundancy, isn't it? We want to have a backup. And also when I'm doing functional safety assessments, and I'm on the FSA 3, the site part, and I walk up to the person who's installing it and I ask them what they understand by common cause failure, and I get a blank stare. So that for me is the weakness of a single source. And if it fails, you can potentially lose your whole database. So you're going to have to really consider how robust your system is. It's going to be a duplicated single source because you're going to have some redundancy. And then there's that other one-liner in 61511 about cybersecurity, the hacking aspect, the firewall, and how robust it is in terms of stopping people from getting into your system and manipulating it in some way, as we've seen in state-backed hacking attacks on other systems.
Okay, thanks. Another question I have here. This is possibly you, Peter. Currently, the Sonosco software SIS Pro 4 cannot be considered a single source for all process safety studies and SIS data. Will SIS Pro 4 be upgraded to single source 2?
So actually, SIS Pro 4 will be integrated into the Sonosco IMS suite and will be rebranded as IMS SIS. So the loop that we've seen before, this SIS loop that we've seen before in the picture, will be covered completely basically then by the IMS SIS software. So IMS SIS will have a HAZOP module, it will have a LOPA module, design verification module, scheduling module, condition history module, just as you've seen in that little diagram that we've seen before. So it will cover the whole SIS lifecycle, including syncing and moving data from one module to another. So SIS Pro 4 will not be integrated into will not be upgraded. It will be integrated. So for greenfield projects, that means that if you're taking IMS SIS for future projects, that you can have this this flowing from one module to another, from HAZOP to LOPA. And for brownfield, if you're on SIS Pro currently, the IMS SIS comes with an import functionality that allows you to import in a certain format, so as per a template, an Excel template, with some mandatory fields that need to be filled in. So you can then import with that template your old HAZOPs on your old LOPAs and your old SIFs as well. So to come back to that question, so the question was, I believe, will SIS Pro 4 be upgraded? In some way it will be. It will be rebranded IMS SIS, but a lot of the functionality will still be there that you currently have in SIS Pro 4. Yeah.
Okay, thanks. Then another one I see in the chat. If you use a single data source application for a project, at what point would you freeze the data, or would you have the ability to select a number of freeze points, one for each project phase? So you, Peter?
Yeah, so let me try to answer that one. So the way IMS SIS will be set up is that every document, and we call that an evergreen version of a HAZOP, for example. That is the first version of that HAZOP that has been approved, that has been finalized, approved. So that will be like a master document for that HAZOP. But any stages during a project, or any subsequent MOCs or projects that you might have on a unit, that is covered by that HAZOP report, you can basically check it out into a draft version, do whatever you need to do on it, MOC project, and then once it is finished, you can approve that draft version, at which point the old evergreen will be copied into an old revision, and the new data will override into the new evergreen version of the HAZOP. So by that, you always have the possibility to do projects, to do MOCs without losing any of the prior information that you might have had in there. It will always be stored in that IMS SIS database, and the same goes basically for LOPAs. So LOPAs will also have this revision management applied to them in IMS SIS. So coming back to that question, do you have the ability? for a number of freeze points, yes, you have that possibility. How one project or one company uses that might be different. So there is no one single solution or good solution, but the functionality is there. Yeah, absolutely.
Okay, I think we have time for one more. Got a question here. A CMMS can source your data, but only so much. Where's the best place to leave the incident data, and what are the consequences of that? Who wants to take this one?
Can you repeat that one? That went a bit quick.
Sorry. The CMMS can source your data, but only so much. Where is the best place to leave incident data, and what are the consequences of that?
Okay, so what is the best place to leave the CMMS data?
The incident data.
Or the incident data?
I think we're talking condition history maybe here.
Yeah, I think so. Yeah. So that sounds like a condition history. Yeah, so that depends also basically what the what the philosophy inside a company might be. So there always has to be like one master and one slave. It's the same with CMMS data, with or SAP data sometimes, as we call it. You can only have one master, and the rest will have to follow, will be a slave. And it's basically the same with the data, incident data or testing data. You can also put that into IMS SIS. And make that the master. But it's the same basically as with the testing results. If you have these testing results from your SIF proof tests, if you have currently an infrastructure in place, in SAP, for example, it might often be, a lot of work, a lot of change for a company to bring that to IMS SIS. But does IMS SIS have the capability? Yes, we have the condition history module. Yeah? So we can also do that. We can also store all the testing results in IMS SIS. But yeah, it really depends on a company per company. One company might make a different decision than another, depending on what infrastructure they may already have in place or what procedures they have in place. And you have to train your people. And somebody who's been working with SAP for the past 10 years, he will not be too keen on move this maybe to IMS SIS, because he has to learn something new. Hopefully, we think the best place would be in IMS SIS, but yeah, companies might decide differently.
Clear. I think this was our time for today, gentlemen. We need to close off. Thank you for this very informative discussion on a single source in terms of the safety life cycle. For all the viewers watching, thank you for your time. It was great having you again. Hope you'll join us again soon. Please take note that this webinar will soon be available as a download from our website as well. Before you go, I would also like to mention that you can also check out our just launched IMS SIS project that Peter mentioned a few times. It's listed on our website. You can, of course, also request a demo, so don't be shy. And lastly, we're already planning the next IMS webinar, and we'll share the date with you soon. So keep an eye out for that, and I hope to meet you again here soon. Thank you all.